For this video, we will talk about the pencil of parallels. First, let us know the definition of pencils. Distinct lines L and M with unit normal script E and script N. Script E cross script N is called the pencil of lines. So in a set of P, or script P, whose unit normals are orthogonal to the pencil of lines, script P will be called pencil of intersecting lines if it is time-like, pencil of parallels if it is light-like, or pencil of ultra-parallels if it is space-like. Now we will talk about the second one, or the light-like pencil of parallels. For the remarks, so from the definition of space-like, if they are ultra-parallels, the set of all lines of H2 is perpendicular to a certain line of H2. And the second one, which is any two lines of H2 determine a unique pencil, it is very understandable that for any pair of distinct lines, there will be a unique pencil. Distance in HQ. Let E sub 3 be an arbitrary point of H2. Let E sub 1 and E sub 2 be vectors of R3 such that the set E sub 1, E sub 2, and E sub 3 is an orthonormal basis. So a typical point on the plane through the origin spanned by the set or the points E1, E3 is gamma E sub 3 plus mu E sub 1. So this point is only or is on H2 if and only if. So we have two conditions. The first one is it must be greater than 0, and gamma squared is or must be equal to 1 plus mu squared. So from a theorem discussed from the earlier topics, we may call gamma equals cosine HT and mu equals sine HT. So this T will be called the distance that measures the distance along the line. So our definition for the distance will be, or we define distance that T measures distance along the line. So we have a new definition. If T is greater than T sub 1 but is less than T sub 2, then A of T is between A of T sub 1 and A of T sub 2. Now that we have defined distance between 2 points in the hyperbolic plane, it is necessary to determine which of the properties of Euclidean distance carry over the hyperbolic case. The following is immediate from the definition. So, nato theorem 10, which talks about 2 points of H2. So, if P and Q are points of H2, then the first one, the distance of PQ must be or greater than or equal to 0. So if their distance is 0, then it is understood that the 2 points are equal. And the last one is the distance of PQ is just equal to the distance of QP. Now let us talk about the triangle inequality, or the theorem 11, which talks about 3 points that lies on the same line. So if P, Q, and R are collinear and P lies between Q and R, then the distance of PQ plus the distance of PR is greater than or equal to QR. So let me visualize the theorem. So naroon ko na tayo 3 points that lies on the same line, so they are collinear, and P lies between Q and R. So, ano siya? Then, the theorem states that the distance daw kuno ni PQ plus PR is equal to or is greater than or equal to the distance of QR. So let us talk about the proof. So let us approach the proof in a contradiction way. So if P, Q, and R are not collinear, then P cross Q and R cross Q will not be proportional. It is very understandable because they are not collinear. They do not lie on the same line. So thus P cross Q cross R cross Q is equal to B of P cross Q R Q is time-like. So from the word time-like, they are obviously a pencil of parallel. So in this case, we may apply the hyperbolic Cauchy-Squarce inequality. So using the Cauchy-Squarce inequality, we can get B of P cross Q R cross Q squared less than or equal to B of P cross Q P cross Q times B of R cross Q R cross Q. But B of P cross Q R cross Q is equal to B of P cross Q cross R Q. So magamit na dira og multiplication of vectors which results to negative B PR times B QQ plus B QR B PQ. So that will result to B of PR, so points PR, distance of points PR plus the distance of QR times PQ. So kani si B, this only talks about the distance. Because B of QQ is equal to negative 1, let us let the distance of QR equals P, the distance of PR equals Q, and the distance of PQ equals R. So from that, we can substitute it using the definition earlier, the definition of gamma and mu. So let us use the gamma, which is the cosine HT. Then, cosine HP is equal to negative B QR, cosine HR equals negative B QP, and cosine HQ equals negative B PR. Thus, so ato lang ning gi-substitute ang atong gilet ganina sa P, Q, and R. So, B of P cross Q, R cross Q is equal to cosine HP times cosine HR minus cosine HQ. Also, B of P cross Q is equal to negative B, P, or the distance of PP, times the distance of Q and Q plus the distance of RQ squared equals negative 1 plus cosine H squared R, which is just equal to sine H squared R. And similarly, the distance of R cross Q is just equal to sine H is equal to sine H squared P. So from the equation earlier, which is kanisha, the equation 7.5, that will become, gisubstitute lang nato itong mga values ganina, diba? So kanisha, cosine HP, cosine HR, minus cosine HQ, kanisi sine H squared R and sine H squared P, that will now become cosine HP cosine HR minus cosine HQ squared less than or equal to sine H squared R times sine H squared P. Hence, extracting the square roots of both sides, it will now become cosine HP times cosine HR minus cosine HQ less than or equal to sine HR sine HP, which results to cosine HQ greater than or equal to cosine H of P minus R. So, nagamit ang dadari o trigonometric identities. So, kay the same naman sila cosine H. Divide both sides by cosine H, which results to Q greater than or equal to P minus R. And P will now become less than or equal to Q plus R.